Good day everyone. So for today, I'm gonna explain how I can write electron configuration from those three elements that I will choose. And also, I will mention the following: orbitals, energy level, valence shell, and also valence electron. So let's start. So to begin, I will explain what is the definition of electron configuration. So the electron configuration is the summary of where the electrons are around a nucleus, or it is also a way of arrangement of electrons on an atom by showing the distribution of those electrons throughout the orbitals. So let's start. So from this, as you can see, you can observe the nucleus. Nucleus is the center circle from it, while the valence shell is the outermost shell of an atom. It is known as valence orbit. And the valence electron is an outer shell. So this is the valence electron, the dot from outer. So it is an outer shell of an atom that can form a chemical bond with another atom, while the energy level is also called the electron shell. So we have first energy level, second energy level, and the third energy level. And lastly, the orbital. So the orbital is the three-dimensional description of the most likely location of an electron around an atom. And there is four types of orbital, which is the s orbital, the p orbitals, the d orbitals, and the f orbitals. And those orbitals have corresponding value. And another thing that we need to remember is from different energy level, there is a corresponding value. So the first energy level can hold up to 2 electrons, while the second energy level can hold up to 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons. And the third energy level is same to the second energy level, which can hold up to 8 electrons also. So from the previous lecture, we all know that orbital is a mathematical function that describes the wave-like behavior of an electron. In other words, the term orbital explains the exact movement of an electron. So, in an electron, a subshell is composed of orbitals. As you can see, the s orbitals composed of shell, p orbital composed of shell, d orbital composed of shell, and f orbitals composed of shells. So s shell can hold up to 2 electrons, while the p shell can hold up to 6 electrons, while the d shell can hold up to 10 electrons, and f shell is equals to 14 electrons. So these electrons are in the same energy level but different from each other according to their spin. So they always have an opposite spins. When electrons are filled into the orbitals, they are filled according to the Hans rule. So, to remember, shell is the pathway. So, shell is the pathway followed by electrons around an atom, and subshell is the pathway in which an electron moves within a shell. So based on my previous discussion, we all know that 2 electrons can fill an s orbital, and 6 electrons can fill a p orbitals, and 10 electrons can fill d orbitals, and 14 electrons can fill f orbital. But we haven't discussed in how these orbitals get filled. So, the order in which electrons are placed into the orbitals is based on the order of their energy. So, this is referred to as the Aufbau principle. So, the lowest energy level orbitals fill first. Just like the quantum numbers themselves, this order was determined by calculation, and it is summarized by the following chart. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and go on. So if it's not present or you didn't write it, you just use the periodic table in order for you to determine this kind of chart. So, as you can see, we have a chart, we have the corresponding orbitals, so we gonna find the electron configuration of the 3 elements that I will choose. So, the 3 elements that I choose is, first is the Be equals to beryllium, which have 4 atomic number, and Al is equivalent to aluminum, which have 13 atomic number, and oxygen, which have 8 atomic number. So let's start computing it using the chart or the electron configuration. So let's start. So from this, so let's start from Be or beryllium. So to get the value or the electron configuration of beryllium, we need to put first the 1s. So s is equivalent to 2, can hold up to 2 electrons, so we're gonna write it 1s2, and the second is 2s. So same as it is equivalent also to 2, so 2 plus 2 is equals to 4. So that is the electron configuration of beryllium. And the next one is aluminum. So in the aluminum, we need to write the same. So 1s2, 2, 2s2, so 4, and then the third is 2p, so p is equivalent to 6 electron, so 6, so 2, 4, 10, so 10, so we only need 13, so we need 3, so we need to write the next, which is the 3s2, and then the last one is 3p. So, from these 2, 4, 6, 8, 10, 12. So, P is equivalent to 6. But we only need 1. So, we need to write 1 only to completely determine the electron configuration of aluminum. So, we need to remove the 5 electron and only 1 is included. So, 2, 4, 10, 12, 13. So, the electron configuration of aluminum is 13. So, the next one is oxygen. So, 8. So, we need to 1 S2, 2 S2, and so 2P. So, we need only 4. So, 2P we need to remove. So, 6 electrons so P can hold up to 6 electrons, but we only need 4. So, we need to remove the 2 electrons from P orbital. So, we need 4. So, yeah, that's all. So, 2 plus 2 plus 4 is equivalent to 8 atomic numbers. So, that is all. And I hope you learned something new. Thank you.